What did I do? Why are you not defining the workflow?
Hi, everybody. Let's go ahead and begin. A couple quick announcements before we get started. This is the last week of Unit 2. We got this class, and then actually one of the announcements, you probably saw the sign on the door as you walked in saying the center will be closed on Thursday. That's actually true, but we still have class. So it will be closed during the day. You will not be able to come here during the day on Thursday, but I've been told that they will be open by 5 o'clock at the very, very latest, perhaps even earlier. So we are still gonna have class on Thursday. It's the last day of Unit 2 coming up. Please come, please be here. You have an assignment due that day, I believe. The last assignment of Unit 2, blogs, is due on Thursday, although as we've stated a few times, the official deadline for Unit 2 is, what is that, May the 6th? Yeah, something like that. And then Monday of next week, we have a study session. And along with that study session, we have a guest speaker coming in from MasterCard. So if you're interested in hearing more about what it's like to go through the launch code process and what they're doing over there, please feel free to come in on Monday. If you need help with the assignment, the last assignment or any of the assignments, please come in on Monday. And then it's possible that there might be other times that we have little study sessions besides Monday, but as of right now, that's the only one we have scheduled. I would encourage you to speak with your TAs about that. They might be organizing individual times as well. And of course, we're always available on Slack or other forms of communication, but we will not have class here next week. So you're not required to come on Monday, but we do encourage you to come, especially if you want to see the guest speaker. And there's no class on Thursday next week either. So enjoy the week off. What questions do you have about deadlines, assignments, other upcoming things before we hop into today's stuff? Any questions? Alrighty. So today we doubled back to a topic that I promised we were going to speak more about. This is more of a security related topic, a security kind of deal. So let's talk about that a little bit. What is hashing? What am I actually doing? If I say I'm going to hash something, what am I actually doing? What does that look like? Encrypting it? Kind of. Encryption, I think, implies something a little bit different from hashing. They're similar in some ways, but I think encryption implies something a little bit different. Or I guess hashing could be considered a sort of a subset of encryption, maybe. What's the difference between encrypting something and hashing something? I'm sorry? Encryption implies that I can decrypt it later, that I can go back. But with hashing, I cannot. Or I hope I cannot, at least. That's part of what we're banking on with hashing. Hashing, I only want to see it go in one direction. And we're going to talk about that a little bit when we talk about properties of hash functions, but what actually is a hash function doing? Does anybody have an idea? Like, we gave you an example in the prep work of a hash function. What was it doing?
Making the data indecipherable.
Making it indecipherable? What actual operations was it performing on that information? Rotation function? Rotation would be an example of encryption, which I suppose you could, it would not be a very good hash function. Another example that we gave in the prep work was just counting letters of the alphabet. Which number of the alphabet are you? And then summing those values up and turning that into a value. Another example of a kind of a poor hash function. But really, what does a hash function do? Some form of arithmetic. I give you a string or a series of bytes, and then you're going to perform some form of arithmetic on that to produce some other number. What is that number going to be? I don't know. Anything. Hopefully some very large, indistinguishable value that people aren't going to understand from just looking at it directly, right? So what are some properties then that we're looking for hash functions? We already talked about one. Hash functions, we say that they're one way, meaning that if I hash something, I give you my password and I hash it, it spits out this whole long string of stuff. But I can't easily go back the other direction, right? If I give you this whole long string of stuff and say, what was the password that I used to make this? You can't tell me, not very easily, right? It's very, very difficult, if not impossible, for us to go backwards from that. Does that make sense? So then encryption is sort of the opposite. We saw Caesar, we saw Visionaire, those are examples of encryption. I could decrypt them, I could go backwards. I just had to understand how the process worked. With hashing, it's not true. So what are some other properties that we like of hash functions? What are some other properties? Yeah?
No collisions, you can't have the same outcome.
No collision. So what does a collision refer to?
Cases where you can get two results from the same input.
So I give you two different inputs, but I get the same value back out. That's called a collision. So in other words, if I give you my password and it generates some long string of garbage, and then you put your password in and it generates the same long string of garbage, that's a problem. That's a collision, right? Because now I have no easy way of distinguishing your password from my password. They could actually be the same. In fact, not unusual for people to have the same passwords. But if they're two truly different passwords, we do not want them to hash to the same thing, because that means they could type in somebody else's password and still get access to your account. So we want to reduce the number of collisions. Can we avoid collisions entirely? We actually cannot. It's very mathematically difficult to avoid collisions entirely. So the best we can do is try to minimize the number of collisions that we have, and basically the way that we do that is to have a very large number of options available to us in terms of output. If the outputs available are small, the range of outputs is very small, I'm going to have lots of collisions. But if the range of outputs that my hash function could produce is very large, then hopefully the amount of collisions that I have will be very, 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 very small in comparison. What are some other properties? I think two more. Repeatable, what do we mean by that?
Every time you run the same input in, you're going to get the same output.
Right, yeah, so another word we would use for that is deterministic. So if I give you my password and you produce this value, I come back tomorrow and I give you my password, it should give me the same value as it did the first time. Come back next week, I give you my password, should still give you the same value as it did the first two times. So I want it to be repeatable. I want it to always generate the same value for the same password that's given to it, for the same starting value. And there's one other thing that we want our hash functions to do for us. Fast. We want them to be quick, because, I mean, think about large applications, how many users they have, how many people are logging in, logging out at any given point in time. It's a lot, and we need to be able to check that quickly. The good news is that that's actually a pretty easy one. A lot of times hash functions are just going to be simple arithmetic operations, multiplication, addition, things like that, and computers can do that stuff very quickly, very, very fast. So as long as you stick to sort of those basics, you're not going to have an issue with that one. The ones that are more difficult to address are the collisions, I mean, really, the collisions one is the one I care about the most, I guess. The one that we have the most control over, I suppose, when it comes to hash functions. Although we do have control over all of them to some extent. Any questions about that? Any questions about what a hash function is? I've been using it for passwords, but we've actually seen hashing used for other stuff as well. Does anybody know another example of what we use hashing for? Cookies. We saw it with cookies last week. So the question I asked you last week was, how do I keep users from messing with cookies? If I store them in just plain text where they can see the values, the answer is, well, you don't. You don't stop them from messing with cookies. They're just going to look at the values and play around with them. Why wouldn't they, right? So we hash them. We hash them, which turns those into, turns those values into much harder to manipulate values, much, much more difficult to manipulate values. Hashing is used in all kinds of applications, though. Consider even just the simple act of accessing a web page. I go to a server, I want to access a web page, it sends me some information back. Oftentimes, a hash code will be part of that information that's sent back to me so that I can verify that what was sent to me is actually, in fact, what the server intended to give to me, and that nobody stepped in the middle and inserted some other undesirable stuff into the web page that was sent back to me. If they did, the hash value would be something different, right? When I recompute it, I would recompute the hash and compare the two answers. If somebody tampered with it, inserted something in the middle of that document to try and get my information somehow, when I recomputed that hash value, I'd see that they were different, and I would know that the document's been compromised and throw it out and ask for it all over again. Hashing is a very, very, very common thing. Another super, newsworthy use of hash functions. You guys have probably heard of something called bitcoins. Anybody own any bitcoins? No? That's probably a good thing. Bitcoins are, a large part of how bitcoins get generated. They are still making new bitcoins. I don't know if that's the proper way of saying it, but new bitcoins still get introduced into the world, and part of the way that works is by hashing. Computing hashing as fast as you possibly can. It used to be that if you had a computer, you could just do hashing on your own laptop, and that would be sufficient to earn yourself some bitcoins. Nowadays, you need to have lots and lots of horsepower to make that happen. It's become more and more difficult to perform that quantity of hashing that's required to generate those bitcoins. Sort of a side note, I remember seeing when bitcoins came back out in 2012, 2013, they were still worth like $5 a pop. I'm really kicking myself about that one. At the time, it seemed like a really dumb idea, and actually, it still kind of seems like a silly idea. But now it's a very worthwhile, make you a lot of money, silly idea. So, anyway, enough on that one. Talk to me about that later if you want to hear more opinions on bitcoins. Let's talk about how we actually do hashing. So we have a Python application called FlickList. We want to employ hashing. That's what you're going to do in Studio today, actually, is do some hashing kind of stuff in your application. How do we actually do that? Are you going to write your own hash function? No, why not? It's not that it's hard so much. I mean, writing a hash function can be very, very straightforward. Oftentimes involves just multiplication and addition, like I said. So writing a valid hash function is actually pretty straightforward. Writing a hash function that nobody's going to be able to break, however, is a more difficult proposition. So writing a good hash function, not so hard. Writing a secure hash function, much more difficult, and not our responsibility. We also don't want that responsibility. I don't want that responsibility. That's not something that I'm really an expert at. It's not something I have a huge background knowledge in. So other people who are much better at those kinds of things than I am have written some very widely used hashing functions. Some examples of which are present to us, like what? Available? What was the one you used in the prep work? SHA-256, very common one. There are others. Anybody know of other ones that they might have seen floating around? MD5 is another common one. There are lots. There are lots and lots. Interestingly, you'll see that over time, some of the older ones, people figure out that they're not as great as they used to be. Computers are getting faster. It's getting easier to do more computations in less amount of time. And as that happens, the older hashing functions that we've been using become easier to break, and so they get phased out, and we have to make stronger ones. A lot of times by stronger, we just mean bigger, right? More numbers, more information being produced as a result. Makes it more difficult for us to check, possibilities of our hashing functions. But you won't have to write your own hashing functions, at least not for security purposes. You'll use, predetermined hashing functions. Every once in a while, however, it is worthwhile to write your own hashing function. That is not an unheard of task. If we're comparing things that don't have a security implication, I just want to see if this thing is the same as this thing. A hashing function is a very, very quick way of doing that. Run both of the things through the hash. If you get the same value back out, they're the same thing. If they're two different numbers, they're something different, right? So if you're not worried about security, writing your own hash function, still a very common operation, still something people do all the time. All right. Last but certainly not least, what does it mean to salt a password? What is that referring to? Why do we salt passwords? Let's start with that one, actually. Why do we salt our passwords? What's the big deal? Rainbow tables. What's a rainbow table? Prehashed stuff. So we take a list of words that we expect people might use for their passwords, or words that we know people have used for their passwords, and we just run them through the hash function, and then we record the result. That's a lot of stuff, right? That is a huge amount of information. You consider all the possible passwords that might exist in the world. That's a lot of information, but it's actually, still very reasonable for a computer to handle that amount of information and to do so in a quick amount of time. That way we don't have to go backwards, right? The whole, I guess, security benefit of hashing is that if I start with the hashed value, it's very difficult for me to go backwards. A rainbow table says, well, forget about that. I'm not going to worry about going backwards. I'm just going to pre-compute everything. And then it's easy for me to check to see if I have any matches. How does a salt help that problem then? How does a salt help solve that problem? What is a salt? What does that do for us? Yeah, we generate some random information, and then when I create an account, when I make an account on a website, I type in what I want my password to be, and then the website takes that randomly generated chunk, that's called the salt, it's usually just a few characters, and tacks it onto the end of my password. As far as I know, my password is whatever I typed into the box. But the website thinks that my password is whatever I typed into the box plus this random stuff. And that random stuff is the key piece, because now if I'm trying to run through common passwords into a hashing function, well, it's not going to work anymore because I've got this extra random stuff on the end of each password. I now have this random information tacked onto the end. That's not the whole story though. So what happens then? So I make an account, I type it in, it tacks this random information onto the end. What happens when I go back to that website a week later and I try to log in? What does it have to do? It has to get that same chunk of random information back, right? That same chunk of information back, tack it onto my password again. So now I'm not just storing am I storing the password? Am I storing the password directly? No, I'm storing the hash. That's very, 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 very important. And I'm also storing the salt. I'm storing them both. I need both pieces of information to properly log a user in and out. Storing the hash is extremely important because, even if we protect our users properly, we hash their passwords. If we're storing their passwords in plain text in our database, if somebody gets our database, that's game over. And that happens all the time. It's all the time. Or not even if it's a hacker. Think about just developers. Think about people who are working on these websites. If one of them gets angry at one of the users or is, untrustworthy for whatever reason, they can just go in the database and start picking people off, using their information. So we're protecting it from ourselves to some extent as well. So it's very important. Huge security tip. Hopefully you already know this one, but if you ever use a website that sends you your password in an email, like your actual password in text, run far, far away. They are storing your password in plain text. That's what that means. A website should never be able to tell you what your password is. They should never be able to tell you what your password is. All a website or other application should be able to do is tell you whether the value you typed in is your password or not. There's a big difference, right? They can tell you whether you've typed in the correct password or not, but they should not be able to tell you what the actual password is. If they can, then they're not storing your information securely, and you should get the heck out of there as fast as possible. And change all your other passwords too while you're at it. Yeah.
Quick question: if the database is compromised and the salt is stored with it, couldn't you just go and regenerate the remote?
Yes. So if the salts are stored, then yes, you're right. We are in a bad position again. However, think about how we use the salt. I have to know what the original password is, tack this random salt onto the end of it, and then hash it to see what the value is. So I'm still in the position of having to figure out what that first chunk, what the actual password is for each individual user, which granted is a little bit easier if I know what that salt is. I agree with that entirely, but that salt is different for every single person. I'm not gonna reuse the same random chunk for every single person. So this idea of creating one table that provides me access to an entire website still doesn't help me. It makes it a little bit easier to get a single account, but it's gonna be a lot of work still. It's gonna be a lot of work. And to get lots and lots and lots of accounts, very, very difficult, even with the salt. Yeah.
Questions, please. On hashing, you said it's pretty common to create your own hash, you're not concerned about security.
Mm-hmm.
What would be a purpose, for example, the reason you use a hash that's not security related?
The classic example is if I'm just checking to see if two things are the same. I just want to know whether this object that I have over here is the same as this object that I have over here.
Why hash it?
Why hash it? Because hashing is very quick. So think about the alternative to hashing. The alternative to hashing would be go through the object, visit every single field, which could be a lot of them, right? And then, check each of them individually. It could take a long time, whereas hashing, by definition, is intended to be quick.
You're turning everything about that object into a number, essentially?
Yes. Yeah, taking that entire object, boiling it into a number, and then comparing that number, which is a much easier comparison than visiting each field one at a time and checking it in a lot of cases.
And then with the password thing, it's almost daily that some websites compromise and we hear about our usernames and passwords are stolen.
Mm-hmm.
Are major companies not doing this most basic of thing? How can your passwords ever be compromised?
That's a good question. Yeah, so some of them, yes, are not doing this most basic of things, believe it or not. However, it's gotten a lot better. I remember a time, back in probably around 2010, 2011, when it felt like I was getting a new debit card like every other week, because they just kept going down left and right, and it's not as bad anymore. A lot of times what we see now isn't necessarily that passwords are getting hacked, although that does sometimes happen. But a lot of what we're seeing now is other information is being left out in the open, like credit card numbers. So what? I don't need your account if I have your credit card number. I'll just go buy a whole bunch of stuff with your credit card, whatever. Forget about your password. Or even just security information. So, a lot of times you need an address or a zip code to use your credit card. If I can easily access that. Privacy, confidentiality has become a lot more important now than I guess it was important before, but it's really, sort of come to the forefront in terms of people's awareness. So even exposing addresses of customers is a breach. And that stuff's going to be in the database. That's not going to be hashed a lot of times. It's not useful to us if we do. So a lot of the hacks that you'll see nowadays will be related to other information. When you see passwords, it almost is likely because somebody screwed up and did not follow these protocols, which is more frequent than you might expect. A lot of times companies, especially larger companies, they don't evolve very rapidly. It takes them time to adopt. Or they might have some application that was written back in 2005 and it's still working, so why am I going to spend a bunch of time and money to go back and redo the whole thing? Well, things were different back in 2005, and if it's still using the same security protocols that we were using back then, it's going to be pretty easy for somebody to come in and hack it. Not to mention the fact that there's a continuing arms race between hackers and security professionals. As soon as we patch one hole, the hackers are out there finding other ones to exploit. And so it just goes back and forth like that, and will continue to go back and forth like that basically forever. Security is a great topic if you're interested in that. There's certainly a lot of careers in that. I don't think Launch Code is particularly equipped to send people down that path, at least not directly. But if you're interested in that, you should definitely take a look, because it's a big deal and will continue to be so. Any other questions? Yes? I'm sorry? Is salt a fixed number of characters? I think a lot of times it is, but it doesn't necessarily have to be. It could be any length. I'm not sure if there's a security advantage to changing the length of the salt. I kind of doubt it, but I also don't think it would hurt anything. You don't want it to be too small, I guess, would be the one thing to be aware of. Don't have it be like one character. That's not going to work. But as long as you hit that minimum, it can be really just about any length, and it won't compromise the integrity of the process. What other questions do you have? Any other questions? Yeah.
I didn't understand. So when we store the hashed password in the salt database, I'm going back to log in. I don't know what the salt is, and I just type in my normal password.
Yes.
I still get logged in anyway.
Yes.
So how does, I guess, the app know what my salt is?
Yeah, so it's storing the salt for each user in the database. So when I go to log in, I type in my username, and then it looks up that user in the database, grabs the salt, and then tacks it onto the end of whatever I typed into the password box before running it through the hash function, right? If I type in the wrong username, then the password's gonna fail the process, right? So it is dependent on whatever I type in that username box. Yeah.
I think in the walkthrough how it stored it was the actual hash and then a comma and then a salt.
That's correct. Yeah, it stored them all in the same place, which is not uncommon. It's also perfectly acceptable to store them separately. Here's the hash and then here's the salt. Just make a separate column for the salt. I've seen that implementation as well. But there's no harm in storing it side by side. It's a little bit more work to store them side by side, as you saw in the prep work, with the comma in between. But it's not that bad. We'll get some practice with that on the studio today. Again, though, just to reiterate, notice that even with the salt, I type a thing into the box, and at no point in time does the server actually check does it actually know what my password is. It takes whatever I told it, tacks the salt on the end, hashes it, and compares it against the hash. It's not actually remembering what I typed into the box at all. As soon as it knows I am who I say I am, it forgets all of that information and moves on with its day. Any other questions you got? Great questions. Fantastic. There is no walkthrough today. However, we didn't quite finish the studio from last time, and it was also kind of a tricky studio as well. So what I was hoping to do for the next, 15, 20 minutes was kind of go back over the studio from last time. If you already finished the studio, you just feel like you know what's going on, then feel free to continue working on blogs or whatever else it is that you wanted to or starting on the studio or whatever else it is you wanted to achieve today. But I'm going to switch over to the studio from last time and just kind of do a quick recap. Like I said, probably won't take longer than 15, 20 minutes. And there are some concepts in here that I feel like are very important for people to grasp. Just to recap, it has been a few days since we looked at this. We told you what we wanted you to do, but we didn't give you much examples to start out with. We just kind of gave you a push and said, go for it. So we wanted to set up a relationship between the user and the movie class. The reason being that right now, when I log into the Flicklist website, or I guess last week, each user would see the same list of movies. So there was like this one big community list of movies. It wasn't tracking it on a per user basis. So we wanted to fix that. We wanted to make it so that each user had their own list of movies assigned to them. And so we did this in class last Thursday, but I wanted to go back through this part because it is a tricky piece, and I just want to make sure everybody's sort of on the same page with me here. In the models file, you can see the models for our user and our movie. And the big thing that we did, it was really just 2 lines of code, I think. Maybe 3. No, I think it was just 2. There's this line here that specifies that we have a relationship, and then we also have this new, I guess it was 3 lines of code. We also have this line down here, which creates a new owner ID column. So owner ID column, we can see by definition is a foreign key, which means that we expect it to point back to the users table. And in fact, we say as much here. We expect this to refer to the ID of a user. That's what this is saying. And then this line up here is also making the user object aware of this relationship. If you look up the documentation on relationships in SQL Alchemy, which I encourage people to do, I was actually poking around at it a little bit before class. You'll note that when we specify a backref here, what we're really doing is opening lines of communication between these two objects. So a user knows that it's got a relationship with a movie row, and vice versa. A movie knows that it has a relationship back to the user. And so we're really just telling it, how does this communication actually work? How is this communication set up? The user ID from the user object is going to be a foreign key in the movie table. So that was the big piece here. And one thing that I didn't do last Thursday that I wanted to show you now, I did this before class. I didn't actually reconstruct the tables, but I did do this before class. And you can see now that my movie table has this additional column, owner ID, or if I go into structure, it'll even give us a little bit more information. See that gray key there? It's indicating that it's actually a foreign key. Right? It's a foreign key pointing back at my user table. My user table looks pretty much exactly the same though. I didn't add any columns to it. I didn't really do anything. So it's pointing directly back here at the users table. Why is that key there? It says it's an index. I'm sorry? Oh, because unique is true. Yeah, thank you. Thank you. Okay. So that's how our table structure is updated based on this relationship between the user and the movie. Now, we also did some refactoring here. We kind of cleaned up our code a little bit. You can already see that I took the two models and put them in this models file. I took some of the application code and put it in a file called app.py, just to kind of refactor things using the MVC approach in mind. But one thing that we didn't do, what I want to do next is start up this application and then see what it does and what it doesn't do, so we can clean up the last couple things that we needed to do. All right, it's up and running. Let's go to our website here and see what happens. So it wants me to log in, which makes sense. I deleted everything and recreated the table, so I don't have any users. I have no users whatsoever, so I have to create a new account, which is fine. I can do that real quick. And register. Okay. And so it happily, shows me my watch list, which is empty because I just started, so there's nothing here. If I go back to the database, you can actually see that I'm now in here. Oh gosh, don't look at my password. You're gonna fix that. You're gonna fix that today, so you won't be able to see what my password is. But I still don't have any movies in the database, so we can test that out as well. If I go back to my website here, and you already know what movie I'm gonna add in to the database. We'll go ahead and add it. Whoops. All right. I got some kind of an error. What did I get? What happened? Let's figure out what the problem was. It says, this line right here. What's this line of code trying to do? This is the line that looks like it failed. What happened? Does anybody know?
Look for the first user with that email.
Or the email associated with the one session.
Yeah, it's trying to find the logged in user, right? But somehow it didn't succeed. So what happened there? Did I screw something up? Or there's my email address. That looks good. So what happened? Does anybody know? I'm not sure I know. We'll figure it out though. I'm sorry, what did I do wrong?
Is the syntax off?
Syntax might be off. That's certainly possible. What line was that? I should have looked at the line number. Line 137. All right. Let's go to line 137. This line right here, what's it, does it look off? No, I mean, that's just a variable name, so that's totally fine. Well, session's right here, so I am using
And
session.
it's fine using it as a dictionary.
So did we actually make sure to store the session properly when we logged in? I guess that's something worth checking. That's the log out. Where do we actually log in? Login's right here.
User, not
Yeah.
User, not the email.
This line right here, is that what we're talking about?
Yeah.
What's it says session user equals user.email, so it should be, oh, it should be user. Got it. Got it. Thank you. Took me a second, but I got it. Thank you. Good eye, man. I would have stared at that for another 10 minutes. Let's try again. All right. Matrix has been added to my watch list, and I go back here and it says the matrix, so that's good. However, if I log out and I choose, I make a new account, you know, I actually have a Gmail account I can use as well. You don't know what my password is.
No.
I'm a different user now. I know my emails look very similar, but they are different. So I'm a different user now. You can look at the database to verify that. And this movie was on my list. So that's not right. It's not picking up the movies that I specifically had put on my watch list. So, you know, I could add another movie for this user, log out and then log back in as the original user, and then I would see, you know, both movies show up on my list. This is what we're trying to fix, and we didn't quite get there last time. So now both movies show up on my list. That's not supposed to happen. I want to see only the movies that I have specified on the list. So let's go back and take a look at our database. Now that we've entered some movies, if I look at the table, you see that we've actually made some progress here. Here's the matrix, here's Finding Nemo, but the interesting thing is the owner ID says that this movie is owned by whoever has this user ID, and this movie is owned by whoever has this user ID. And we can verify those by, you know, looking back here, seeing that, okay, that makes a lot of sense, right? I have two users that each own a different movie, but my website's not taking that into account. So where do I expect to fix this problem? Where in here is this problem actually happening? At which handler? It'll be, I mean, there's a lot of code here, right? Where do I even begin? That's sort of the question. There's a lot of code here. I don't want to go through this line by line. So what can I use to help me narrow down where I should be looking? Anybody have any ideas? Which page was I working with? Which page is this? This is called the index or the root. The root. So whatever's doing the root handler is what's generating this list here, right? So that's what I need to take a look at. Actually, if you go take a look at what the studio tells us to do, it says down here, when the user visits there it is, the root. And we also have this ratings page, which we need to fix as well. I haven't even talked about that one yet. We'll get there anyway. But right now, we're seeing everybody's movies. We want to fix this so that we just see whoever's currently logged in. So let's go find the handler for the root, which is right here. It's actually not very big. Index, not very big. See if we have any errors. Get current watch list is what dictates what movies I see on this page, right? Get current watch list. So what is that doing for us? Get current watch list is up here somewhere. Movie filter query by watched equals false. What's the problem?
You have to add another filter.
We have to actually filter it by the user, right? So specifically we want to filter by the user ID. So how do I get that user's ID? That's sort of the next question. How do I get the ID of the user that's currently logged in? From the session? What's the session storing for us? It's storing the email address. So based on the email address, can I turn that into a user ID? Is that possible?
Yes.
Yes, I sure can. I sure can. So what I really want to do is not just get one generic watch list. I want to get a watch list depending on who's currently logged in. And there's a couple ways you could approach this. You could actually check for that right here inside the function, right? Find, who's logged in. And you could do it that way, or another option, which I'm going to do instead. Not that there's anything wrong with that first option. If that's how you did it, I'm totally fine with that. But another way you could do this is with a parameter, right? So specify who the logged in user is, and then use that information to look it up. So this could be by email address. This could be, there's a lot of ways you could take it, but tell me who the logged in user is, and then actually look up this information. Actually, while we're on that topic, let's do another function here. Get logged in user. The reason that I'm interested in making this function is right now the session, as we just said, is storing only the email, right? But we want the ID, and really the way that we need to do that is to access the entire user object, not just the email address. So maybe I can write a function here that's going to grab the user object for whoever's currently logged in. Does that make sense? I want this function to see who's logged in, go to the database, and get the entire user object for whoever that person is that's logged in. So I need a query. This is maybe a one-line function here. Return, what am I going to query? Which table? User.query.filter by, and then what? Email equals session. I'm not going to make that mistake again, but I know what you meant. User dot all. If we expect email to be unique, which it is, all is fine. Or if you want to be super duper safe, you could say first as well. That's fine. This is going to go to the database, grab whatever user is currently logged in, right, and then return the user object there. So then here, let's say that this logged in user is actually going to be not an email address, not an ID, but an object, a user object. How do I update this query with this user object to only get back the movies for this particular user? What do I need to say?
Filter by, make it additional ID equals logged in user.id.
ID equals logged in user.id. So logged in user.id goes to the user object and says, hey, tell me what your ID is. Are we okay with this part? We're querying the movie table. What's that column called in the movie table? It's called owner ID. So we do need to be careful about that. It's called owner ID. I know what you meant though. Owner ID. And actually we could do the same thing for this function right down here. Get watched movies is going to be a similar process, right? Get watched movies. I'll tell you the logged in user. And then update this query to indicate that I only want to see movies for this logged in user. We're actually almost done. It's not going to work quite yet. It's not going to work quite yet. I just changed these two functions. I just changed get current watch list and get watched movies. They did not have this parameter before, but they do now. So anytime I use this function and this function, I have to make sure that this parameter is passed in as well. So one of those places is right down here in our index, get current watch list, right? There it is. I need to figure out the user that's currently logged in and pass it in here. So how do I do that? We made a function for that, right? Logged in user. Was it get logged in user? Is that what I called it? Oh, okay. I trust you as I double check it. I really do. You guys have bailed me out more than once. And then the other function that we used, get watched movies, is that what it was called? Should be in the ratings version, which is right here. Get watched movies, similar process. Get, oh, come on. Logged in user. So again, we didn't add a ton of code here. We tweaked a couple of functions that we already had. We added one new function that was pretty short, and then we updated these handlers to use these new functions. But the main takeaway is that this is the part that actually exploits the relationship. If I had to write a SQL query to do this, what would it have done? I actually had to write the SQL code, select from, what would I have needed to do to accomplish this? We would have needed a join. We would have needed a join. This is telling it to do a join. This is telling our ORM that we need to join these two tables together to find which user ID links up with this particular movie. This is telling it to do a join using that relationship that we specified in the models file. We don't know that it works for sure yet, so let's save everything and go back and try it out. If I refresh this page, what do I hopefully expect to see? I'm currently logged in as this guy. One of these movies, right, should hopefully disappear if I did things correctly. Hopefully. And all right, cool, Finding Nemo is gone. If I log out and log back in as the other guy, I should then see Finding Nemo there as well, right? Oops, I don't want to register. Wrong page, sorry. So there's Finding Nemo, and the matrix is now gone. And now if I click this button, all right, it's crossed off my watch list. This one's empty, but if I go to the ratings page, I see, all right, Finding Nemo's on there. And I can log out and go back to the other guy and see that, you know, their information has remained unchanged. It contains the matrix, and there's nothing on this list because I haven't indicated that this user's watched any movies yet. Our database backs this up as well. If I take a look at the movies, you can see that after I click that button, Finding Nemo now indicates that it has been watched. This user has watched this movie. So now we actually have a relatively functional website. It actually tracks movies on a per user basis and allows me to rate movies on a per user basis, which is great. It's taken us a while to get here, but this is a good website. Now you can go make a competitor to Netflix and make $1 billion. Any questions about that? I think that wraps up the studio. I kind of ran out of time last time, and it was an important studio, so I wanted to make sure I finished it up. But are there any questions? Yeah, in the back? Yeah. How do I know which table needs what? Yeah, okay. Let's talk about that real quick. So here I am, I'm looking at my two models, user and movie. What's the relationship between those two? There's different kinds of relationships, right? Well, there's one kind of relationship that we use basically almost all the time. One to many. So which side is the one and which side is the many? One user is going to watch many movies, right? One user is going to watch many movies. So you can see here that the backref goes on the one side, and down here the foreign key appears on the many side. That will always be the case. That will always be the case.
Where you have movies, second line there, that's referring to your movie class.
Where at now?
Second line you got.
This right here? Yeah, it refers to the movie class, that's right. Which object do I have a relationship with? I have a relationship with the movie object.
And is it always backref owner?
Actually, this backref, there's a little bit of flexibility there. You see that I do have a field here called owner, and some of you may remember me last week saying that these were the same. That wasn't an accident. Well, I don't think it was an accident. However, I do actually think that you could name this whatever you want, and it would still work. So this is more of a reference for the ORM's purpose than our own purposes. I think you can call this whatever you want, but I still think it's a good idea to keep your naming consistent so that you know which fields are part of the relationship. Yes?
I'm still a little confused on the self.owner.
Mm-hmm.
You're saying that, does that have to be owner down there, or you're saying, because you just said you can name that up?
No, I think there's flexibility in terms of what these names could be.
Okay, but what do they, I mean, I don't get that.
Well, so what is this? Self.owner, we have a name for that. We've talked about that since Unit 1. What is that? Same thing as self.watch or self.name. What are those? Attributes, fields, instance variables. There's lots of different things that we've called them over the course. These are just instance variables. I can create as many of these as I want, right? I'm the programmer. I get to decide. Field, right? I get to make up as many of these as I want. So, why did I create this one? Because I wanted a way to track the user that owns this particular movie. That was a need. I needed a way.
Because in the past, they were always column names from the database that you were studying?
Oh, I don't think that necessarily, I see what you're getting at.
Yeah.
I don't think that necessarily is a restriction at all. The column names, I can create as many fields as I want, regardless of whether or not they are columns in the database. If I create a field that's not a column in the database, then I'm not going to store that information in the database, but I can still have that field, I can still use that field, I can still do whatever I need to. And in fact, this field gets used because of the fact that it relies on this relationship here.
I know, but is that just a variable name then?
Sure. Yeah, it's a variable name.
Okay.
Yeah. I don't think that they do. I mean, we can test that. Which one am I using when I use the dot notation? That's a good question. Which one am I touching? Which one am I hitting? Anybody know? If I say user.owner, which one am I hitting? No. Always the instance variable. Always the instance variable. From the object's perspective, if I have a movie and I'm manipulating that movie, this backref is none of my business. It's just kind of hiding out in the background, making sure that everything's hooked up properly as far as the database is concerned. If I'm just doing regular Python stuff, I don't need to know about this. That's not my issue. I'm referring to the object stuff. I'm referring to the fields that the object has.
So you're basically saying the user object is getting stored in something called owner.
Yep.
With that object in memory, right? So you're just giving it a name. So you can call it anything, and when you're referring to that.
Yeah.
Okay.
Yeah, I sure can. The ORM is doing a lot of heavy lifting here for me, which is part of why we use ORMs, is so that we don't have to worry about how everything gets connected up as much. Well, we do have to worry about it. We do have to specify relationships, but we don't have to manage every single detail of how those relationships are connected and made in the database. That's really the power of the ORM. We tell it that this relationship exists. We tell it that we want to connect it to this movie object. We store a user inside of the movie object, and then the ORM connects all the dots for us and makes everything work on the database side so that we don't have to. That's what the ORM is for. If it seems like it's magical, if it seems like there's sort of a little bit of fairy dust that's tying all this stuff together, that's because there is. There is a little bit of magic happening underneath the hood here. I'm not going to stand up here and pretend like I know every single thing that the ORM is doing under the hood, because I don't. Part of the reason I use ORMs is so that I don't have to know that stuff. It just does the work for me, and so I can spend my time thinking about other things. Other things that are, more worthy of my time. And that's pretty common in computer science. Anytime you use a library, anytime I want to use somebody else's code, do I know how that code works line by line? Oh, no. Definitely not. Definitely not. I do have some expectation on a general sense of what it's going to do, right? Otherwise, I wouldn't be using it. But I'm not going to sit there and dissect everything line by line. It's really just not, it's not worth my time to do that. I have to trust that whoever wrote it did a good job, and then it's going to accomplish what I'm using it for. And that's the story here with the ORM. We tell it what information it needs to do its job, and then it does a whole bunch of work for us. And I'm very glad that it does. Otherwise, this flick list application would have taken us probably an additional 2 or 3 weeks to put everything together. What other questions do you have? I know it's a tricky concept, and I'm not trying to be dismissive about it, so if you do have questions.
We're used to this concept though. We use Word. We expect Microsoft Word to act a certain way. We're not dissecting Word line by line every time we use it.
Yeah, that's-
So we do this all the time anyway.
That's a good point. I mean, the applications we use every day, we're also performing similar kinds of magic. And think about, you guys now have a bigger insight into how those programs work, right? How Excel works, how Microsoft Word works. Those are gigantic applications with huge teams of people that work on them. And not even people who are working on Excel know how all the parts of Excel work. They don't have to. They know how the part works that they work on really, really well. They might know how some of the other parts work if they have to communicate, but they're not worried about every single little thing. They don't have to. That's called modularization or compartmentalization, right? Focus on what you're interested in and let other people focus on the stuff outside of your little bubble. Treat it as a black box. It's just gonna magically do what you need it to do. And if it doesn't, you don't have to fix it. You go find the guy that wrote that thing and you yell at them until they fix it, right? Right? That's less work that you have to do. What other questions do you have? Any other questions? I think that's going to do it for me. We do have a studio today on hashing, so I will plan to go through that studio at 8 o'clock. So take a look at that. Otherwise, work on blogs. Let us know if you need help finishing up blogs, or if you're still working on some of the past assignments. Keep chugging away on those as well. Let us know what you need.